All right, last one we talked about perpendicular bisectors. Now we're going to talk about angle bisectors. And we remember that an angle bisector is a ray that divides an angle into two congruent adjacent angles. We also know that the distance from a point to a line is the length of the perpendicular segment from the point to the line. So in the figure below, ray AD is the bisector of angle BAC. And the distance from point D to ray AB is DB, the point where DB is perpendicular to ray AB. So here it tells us it's an angle bisector, and because of that we know to measure from here to here, we have to do it at the 90-degree angle. Which brings us to our angle bisector theorem, which tells us that if a point lies on the bisector of an angle, then it is equidistant from the two sides of the angle. Which means that here we have an angle bisector, and we know because these angles are congruent, and because we're measuring from point D to the rays at a 90-degree angle, that this will be true. So in math speak, it's going to look like this. If ray AD bisects angle BAC and segment DB is perpendicular to ray AB right here, and DC is perpendicular to ray AC. That will be right here. Then DB equals DC, which is exactly what we marked earlier. Now, just as with our perpendicular angle bisector, our perpendicular bisector theorem, the converse is also true. So if we know that a point on the interior of an angle and it's equidistant from the two sides of the angle, then it lies on the bisector of the angle, which makes this true. So the math speak for that is if segment DB is perpendicular to ray AB, right here, and segment DC is perpendicular to ray AC, right here, and DB equals DC, which is this guy here, then ray AD bisects angle BAC. All pretty straightforward. So let's move on and look at some examples of how this might work. So is there enough information to conclude that QS bisects angle PQR? And the answer is clearly no. Because PS and RS aren't being measured at the perpendiculars. So to use the converse of the angle bisector theorem, segment PS must be perpendicular to ray QP, and segment RS must be perpendicular to ray QR. So PS being perpendicular to QP and RS being perpendicular to QR. Must be true. So let's look at some applications. Find the measure GFJ. Well, here we got JG and JH, both being measured at the perpendicular. They're the same. So ray JF is the perpendicular bisector of angle GFH. So angle GFJ is 42 degrees, the same as angle HFJ. Let's find RS. Well, here it shows the angles are congruent. So ray SQ is the perpendicular is the angle bisector. So SR and SP have to be congruent. So we're going to set them equal. And we're going to solve for x equals 5. And then we're going to go ahead and plug it in. So RS equals 6 times 5 minus 5, or 25. Let's find the measure of angle ABC. So here ABC is the big angle. DA and DC we're measuring at the perpendicular. They're the same, so BD is the perpendicular bisector. So we got 56 plus 56 equals 112 degrees for the measure of angle ABC. One more and then we'll get a little more involved. All right. Here we want to find JM. And we've got an angle bisector. We're measuring it at the perpendicular. So 4x is going to equal 2x plus 12. Subtract 2 from both sides, so 2x equals 12, x equals 6, JM is 4 times 6, or 24. So we got to make sure it fits into our definitions. We're measuring at the perpendicular and basically setting a bunch of stuff equal to each other. Do not mix and match the sides and the angles. So this next one's a little more involved, and we're going to have to remember a lot of stuff. So let's start. Now let's just start at the very beginning. We're going to write an equation of a perpendicular bisector of the segment with endpoints P, which is minus 2, 3, and Q, 4, 1. So we're going to start off, and we're just going to graph PQ. So there's our P. 1, 2, 3, 4. And there's our Q. And there's our line. Then we're going to move on to step 2. And as we recall, the perpendicular bisector, bisect means cut in half. So we're going to find the midpoint of PQ. Well, the midpoint formula looks like so. So let's go ahead and plug in our x's and y's. So we got, for our x's, minus 2 and 4. Our y's, we got 3 plus 1. So minus 2 plus 4 is 2 over 2. And 3 plus 1 is 4 over 2. So m is 1, 2. And somehow I accidentally erased my line, so let's put that back. There we go, 1, 2. There's our midpoint. So step 3. If we want to write the equation of a line, we need to know the slope. So let's find the slope of the perpendicular bisector. Well, as we recall, we do that by finding the slope of PQ, which is the change in y over the change in x. So we're going to take our y's, right, our y's here, and then we'll take our x's, so 1 minus 3 is a negative 2, 4 minus a minus 2 is 6, which reduces down to negative 1/3. So now we've got the slope of PQ. So the perpendicular slope is the negative reciprocal. So we change the sign and flip it over. So it's positive 3. So let's write an equation. We know y equals mx plus b. We're writing the slope of the line perpendicular. And we know a point on that line perpendicular. It's our midpoint. So here's our y. Here's our x. And here is our m. So we got 2 equals 3 times 1 plus b. 3 times 1 is 1. Subtract 3 from both sides. And negative 1 equals b. So the equation the line perpendicular to PQ is y equals 3x minus 1. As simple as that. So take that process and go ahead and complete this one down here. The process is going to be the same. Go ahead and pause the video, work through it, and then we'll come back together. Okay, good job. So, just like we did above, we're going to graph DE. There's our D. There's our E. Okay. And we're going to find the midpoint. Is negative 3, 2. Negative 3, 1. And after we have that, we can move on to find the slope. We're going to do that by finding the slope of DE. So change in y over change in x, we get 4 over minus 16, which reduces down to negative 1/4. And the negative reciprocal is 4. So let's write an equation. Again, we're starting with y equals mx plus b. Our y and x we're pulling out of the midpoint. And the m, we're taking that. So we got 1 equals 4 times negative 3 plus b. So 4 times negative 3 is negative 12. Add 12 to both sides. 13 equals b. So y equals 4x plus 13 is the equation of the perpendicular bisector of segment DE. Two more and we'll be completed with this section. So let's use the figure and the given information to find the indicated measure. So we want to find CD, which is this guy right here. And we know that ray BD bisects ABC. So this is true. And that here we have 90 degrees, so this has to be true. So we're going to go ahead and set them equal, solve. So we get 3z plus 7 equals 2z plus 11. Subtract 2z from both sides, subtract 7 from both sides, and z comes equals 7. For CD, 2 times 7 plus 11. Oh, sorry, it's 4. What was I thinking? Let's fix that one too. That's why we take our time. And CD equals 19. We can check it by plugging it into AD. 3 times 4 plus 7. 3 times 4 is 12 plus 7 is 19. We're good. Go ahead and solve the last one, and then we'll work it through together. All right. So let's find the measure of ABC. When AD here is 3.2, and CD here is also 3.2. Well, DA is 3.2. We're measuring at a perpendicular to BA. DC is 3.2, and we're measuring at a perpendicular to BC. So BD is the perpendicular bisector of angle ABC. And since DBC is 39 degrees, ABD also has to be 39 degrees. So the measure of angle ABC is 78 degrees. And we are done.